Hello everyone. This is my last video on normal distribution. In this video, I will be explaining some exercises. First one. Using the following uniform density curve, answer the questions. How do we make sure this is a density curve? Go back to the properties of density curves. Area. Area under the curve is 1. How do we find an area of a rectangle? Length multiplied by width. The length is 8, width is 0.125, then area is 1. Yes, therefore, we can believe this is a density curve. Part 1. What is the probability that the random variable has a value greater than 3? How do we find the probability when we have a density curve? It is the area under the curve. For this case, greater than 3 should be this area. This area gives the probability greater than 3. How do we find this area? Okay, we know already width is 0.125. The length 1, 2, 3, 4, 5, 6. 6 unit. Therefore, 6 multiplied by 0.125, this equal 0.750. So this is the probability greater than 3. Part 2. What is the probability that the random variable has a value between 2.3 and 5? 2.3 I take here and 5 is here. So area we need is this. How do we find this area? Again, length multiplied by width. So here length from 2.3 to 5, you can find the length 5 minus 2.3, that equal 2.7. So now we know the length, therefore probability you can find 2.7 multiplied by 0.125. This equal 0.3375. It means probability between 2.3 and 5 is 0.3375. Next one, find the area of the shaded region. The graphs depicts the standard normal distribution. Find the area of first one. So this area is the left to the value 1.13. In other words, we can say find the probability z less than or equal 1.13. So this is the area under the curve and less than 1.13. How do we find this area? Okay, now we need to use the z table. Z less than or equal 1.13. It means we should find the 1.13 positive. So 1.1 is here. You see that? So 3.03 is here. So intersection is this 0.8708. Therefore, this answer is 0.8708. Right. Yes, it must be greater than 0.5 because this is the half of the density curve. Okay, we will go to next one. Yes, second graph, we have an area greater than negative 1.82. So we can write down this probability z greater than or equal negative 1.82. So we know we cannot find this value directly. from the table. Therefore, we write down always 1 minus probability z less than or equal negative 1.82. This. Again, this is greater than or equal. Therefore, we have to make it less than or equal. How do we do that? 1 minus probability z less than or equal negative 1.82. Now go to the table. Negative 1.82. It should be negative number here. 1.8 is here. And 2 should be this. So therefore answer should be 0.0344. So 1 minus 0.0344. Therefore this should be 0.9656. So that is the probability of area under the curve and greater than negative 1.82. Now let's go to the last one. So this has two values. We need to find the middle area. This is the negative 1.08. This is the positive 1.08. So how do we write down this? Probability negative 1.08. This is less than or equal z. And z less than or equal to 1.08. Whenever you have this, the greater than and less than for both, then how do we do? First, go to the bigger number, this number. It is the 1.08. Therefore, probability z less than or equal 1.08. Then always minus. Then go to the small number, which is negative 1.08. Probability z less than or equal negative 1.08. Probability z less than or equal 1.08. Go to z table. Positive 1.08. Therefore, this is 1.0 and 8 is here. So this is 0.8599. 0.8599 minus next one, z less than or equal negative 1.08. Negative 1.08. Here negative 1.0. So you know this is 8. So 0.1401. You know this is 8 here. 8.08. Therefore 1401. 1401. So this equal 0.7198. Now you see the difference of these three. First, less than or equal. Next, greater than or equal. The last one, both less than and greater than signs. Now, area is given. Need to find the z value. In this problem, area is 0.6290 and need to find the z1 value. In probability z less than or equal the number z1. This equal 0.6290. Okay, this is a less than or equal sign. Therefore, we can directly use the z table. Go to the z table, find the 0.6290 in the middle of the table. 0.6290, we don't have 0.6290, but we know 0.6290 should be in between these two numbers and closer to the 0.6293. Therefore, we can consider this 0.6293 instead of 0.6290. This side 0.3 and this 0.03. Therefore, our z1 value equal 0.33. And go to the second one. So second one, we have the area at the right side. This area is 0.1093 and need to find the z2. Probabilities z, this area actually greater than or equal z2, and this is the z2. This equal 0.1093. Now we have here greater than equal. Therefore, we cannot use our table directly. So what do we have to do? We can write down 1 minus probability z less than equals z2. This equal 0.1093. From this equation, you can find the probability z less than or equal z2. This equal 1 minus 0.1093, 0.8907. Okay, now we have less than or equal sign here. Therefore, now we can go to a table and scan for this number 8907. Go to the table 8907. 8907. Yes, we do have this number. Therefore, we can consider this is z value 1.2 and here 3. So 1.23. Therefore, from this you can say z2 equal 1.23. So that is the z2. Next, the midterm test scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Test scores, I take x. X represents the test scores. So then x has normal distribution, mean 63 and standard deviation is 5. Then go to the first one. Find the probability that a randomly selected student is scored less than 74. Okay, less than 74. So this is the density curve for the x. Therefore, 74 should be greater than 63. Therefore, I take here. This is the point of 74. So they are asking the probability in mean area under the curve and less than 74. So this area. How do we find this area? Okay, let me write down this probability scores x less than or equal 74. So this is the probability they are asking. If we had z here, we could use the table directly. But now we do have x. Therefore, we should convert this x to the z. How do we do that? Z equal x minus mu over sigma. So, we can convert this x to the standard normal using this equation. So, we know this is the standard normal, then mu should be 0 and sigma equal 1. So, 74 should be somewhere here. This. So, area under the curve and less than this number should be the same area over here. Okay, now, how do we find this number? just use z equal x. X is 74 for this case, and minus mu equals 63 and sigma equal 5. So this equal 2.2. Therefore, this number should be 2.2. We were looking for probability x less than or equal 74. Now I convert this into the standard normal. So probability z less than or equal 2.2. Okay, now we have z, which is standard normal. Now we can directly go to a table, find the probability less than or equal 2.2. So 2.2, this should be positive 2.2. 2.2 is here. So this is the 0. So this is the number which is probability less than 0.2.2, 0.9861. 0.9861. So what is the meaning of this? 98.61%. 98.61% has less than 74. Part 2. Find the probability that a randomly selected student scored more than 65 on the exam. So I use this is the 65 of x, asking the probability greater than 65 should be this area. So I convert this to the z. So we need to find this area. How do we convert to z? Z equal x minus mu over sigma. So z equal x, here 65 minus mu 63 divided by sigma, which is 5. This equal 0.40. Therefore, this number is 0.40. We wanted to find probability x greater than or equal 65. But now we converted to z. Therefore, we can say probability z greater than or equal 0.4. Now you see we have here greater than sign. If we have greater than, we always write down 1 minus probability z less than or equal 0.4, 0.40. Then go to the z table. This is the z table. We need 0.40. 0.4 here, 0.40 should be this, 0.6554. So 0.6554. Therefore, probability should be 0.3446. It means we have only 34.46% greater than 65. Third one, find the probability that a randomly selected student has C grades. C is given 70 to 80. It means this is X grade. So 70 and be over here and 80 here. So they are asking probability in this area under the curve and in between 70 to 80. So this is the standard normal. So we should convert this to standard normal, this number, and 70. We need to find this area. Probability 70 x 80. So once we have this 70 to 80 range, so first one, we write down the big number first, like this 80, and then the smallest one, x less than equal 70. Now I don't show how to convert z separately. I will show you how to do in between these brackets. Right, so probability, what I do, I convert x to z, x minus mu over sigma, then 80 minus mu 63 and sigma equal 5 minus probability, again x minus mu over sigma 70 minus 63 divided by 5. Once you simplify, you know this x minus mu over sigma is the z less than equal 80 minus 63 divided by 5, 3.4 minus probability z, similarly x minus mu over sigma, and 70 minus 63 divided by 5 is 1.4. Now go to the z table. This is the z table, we need 3.4. 3.4 here. So 3.40, it is 9997. 9997 minus, now we need 1.5. This should be the 0.05. If you go top, is 0.05. So 0.9265. 0.9265. So answer is 0.0732. It means only 7.32% has z in this class. The last one, find the 90th percentile. X has normal, mu 63, standard deviation is 5. So 90th percentile, that means this area is 0.9. So this k is the 90th percentiles that we are looking for. Okay, now consider this diagram. According to this diagram, we can write probability x, because this is x, less than or equal k. You know this is k. This is the probability x less than or equal k equal what? The probability is here, right? Area under the curve, and less than this k, we know it is 0.9. So that is the 90th percentile. Okay, now we convert this to z. As I discussed before, you can write down x minus mu over sigma, which is z, equal k minus mu, we know this, 63 divided by sigma 5, this equal 0.9. Okay, now look at this graph very carefully. You see, we know this distribution, this number and area, we know the area, but we are looking for something in the bracket. It means we are looking for k. Okay, if you are in this situation, then we have to go back to the z table and find the value in the middle of the z table with 4 digits, 0.9000. Let me go to the z table. Okay, this is the z table. Now we need to find 0.9000. 0.9000 is not here, but we know 0.9000 should be in between these two numbers and more closer to this number 0.9000. Okay, therefore we can consider this number instead of 0.900 and find the position which is z value of this number, that is 1.28. Alright, according to the table, it was 1.28 z value. Once you find the z value, we can just write the k minus 63 over 5. K minus 63 over 5, then we can find the k equal 1.28 multiplied by 5 and plus 63. So this equals 69.4. Therefore, our 90th percentile is 69.4. What is this 69.4? This is the k value. 69.4. Alright. Thank you for watching this video.